Okay, so I shared a video of this without comment a little bit ago, but I've updated it, so I wanted to show it off again because I'm like, yay, I made something cool. Actually, this semester I've been writing a lot of little JavaScript applets for my Discrete Math 2 class, just to either solve like a combinatorics problem, or there's the binary sequence problems that tended to trip everybody up. Average value, just to kind of show the computation of it versus actually running a trial. And then the graph theory stuff, so I have like the traveling salesperson problem. The background should load. Oh, there we go. Where they can kind of set up paths, and this shows a distance by pixel, or they can try to build a Hamiltonian cycle on this graph, and they just kind of, they can click anywhere really. It's not double checking anything, but it's there just to kind of help them work through it without having to like use up a bunch of paper. There's also the 7 bridges of Königsberg, and the little wolf cabbage game. This one also doesn't do any error checking, but the idea is if you leave the wolf and goat alone, the wolf will eat the goat. If you leave the goat and cabbage alone, the goat will eat the cabbage. So you'd have to like move the goat over, return, move the cabbage over, and then move the goat back, and then move the wolf over, and then move back, and then move the goat over, type of thing. But what I updated was the graph maker. So before it was pretty simple. I tried to improve the user interface and just kind of the visual cues as well. So now each of these have a different color associated with it, but it also will just tell you right above your cursor what you're doing, because it was really easy to kind of get those mixed up. So you can create some vertices, or you can now change it to ABC. One of my students requested that. You can then connect edges between them, and you can move the vertices around. So that's used in the graph theory chapter when we're talking about planarity and isomorphism. So something planar, maybe I'll give them something like this and just say, hey, redraw it so it's planar, so no edges are crossing, and then they can figure that out here and then write it down on the exam. I also have rename, because if you go on creating a bunch of these and then erase one, it's just going to continue from a different value. So I just added a rename function. I'm not really going to add any sort of like double check what node name isn't used, and then use that. And then I have, before I had erase vertex, which would erase the vertex and any connecting edges. And then I added just recently the remove edge one, which actually took some trig in there. Oh, okay, I have a bug. So the idea is you can remove an edge. Okay, that one's not working. So I might have some more work to do on this, but you can remove an edge like that instead of having to remove the vertex. So I apparently need to like double check my trig a little bit because something is not going right. But for the most part, in testing other stuff, it's been okay. Now that I say that, I'm going to try this out, and it's going to completely not work. So edge. So like this one looks okay, but for some reason the other one wasn't working out. There we go. So I just have some fixing to do. But and then I have a bug where for some reason my stroke color keeps changing over here, and so I might not have like the correct begin path and then stroke commands like 1-to-1, because apparently at some point changing your erase or edge changes the stroke color here, which is really weird. I tried to track that down, but I couldn't. Oh yeah, another thing I did, if we end up using this on the data structures class, you know, they might have some sort of vertex or binary tree that they need to graph, and then they could rename the nodes as needed. So this wouldn't be a binary search tree, but it would be a binary tree. Then they could save the image as a graph. So you click that, it comes up with an image. You can save it. And then from there, they would be able to upload it on their exam. So that's another thing I added. I think this is zoomed in a bit. Oops, I accidentally cleared it when I went to fix the size. But yeah, so I added that in there. That way they can easily just add that in uploads for homework or for exam questions and stuff like that. Okay, so those are my visualizations. Then I have one for Discrete Math 1 where the textbook introduces like, oh, if you kill every other person, who's the last person remaining? 1, 2, 1, 2, 1, 2. And then this is just to help them solve that type of problem, because it's easy to kind of get lost when you're kind of doing that systematically. Okay, so that's all. This is just on my GitHub under Rachel's courses, so I keep all my class stuff here, visualizations, and you can go here to view the website version of it. Otherwise, all of the code's up here.